We all know these names: Hurricane Sandy, Hurricane Katrina, and Hurricane Ivan. Some of the worst hurricanes in U.S. history, and if we look at world history, there have been countless devastating cyclones across the world. But what actually creates a hurricane? We all know that they come from the tropics and that they're called tropical storms, but what is it that is actually creating these storms of mass destruction in the first place? Well, let's talk about the science behind that.
Welcome to The Science Behind That with Atticus Hamilton.
Hello, all you scientists, and welcome on back to the Science Behind That podcast. I am your host, Atticus Hamilton, and as you heard in the intro on today's episode, we are going to be discussing the science behind hurricanes, tropical storms, cyclones, typhoons, whichever word you'd like to describe them. We're going to be talking about that. But before we get started, ladies and gentlemen, I'd like to invite all of you to grab yourselves a nice steaming hot cup of coffee, add a little bit of maple syrup to it, and we will jump right in. So, before we get started, I want to say that I was gone for a really long time, and I'm sorry about that, but I moved again, cross-country. I moved back to the west, back to the Colorado area, from Connecticut. So that was one of the reasons why I was gone for so long, and I'm sorry about that. I know I did lose some of you guys because of that, but I do have a bunch of new episodes lined up here that I'm going to, and I'm really excited to talk about. So I hope that you guys, the ones that left can come back. And for all of you listeners out there that are still listening to me, thank you very much. I'm excited to talk about today's episode. So today's episode was actually suggested to me by a friend of mine back east, James. If you're listening to this, thank you very much for the suggestion. And, on our way to work one day, James was like, Atticus, I have a good idea for you for a episode for your podcast, the science behind hurricanes and, typhoons and whatnot. So I thought that was a good idea. I've never done anything like that before. I haven't really done much weather stuff, but here we are. So, ladies and gentlemen, I hope you enjoy this. This is going to be a fun episode. So, today we're going to be talking about mainly four main things. The first off is, what is a hurricane? What is the difference between a hurricane, typhoon, cyclone? How are they made, and how are they formed, and why is climate change affecting them? Why do people say that they're going to get worse as our planet warms? So those are the four things we're going to be talking about today. So jumping into it, what is a hurricane? Well, all a hurricane is it's basically just a big spinning mass of wind and clouds and precipitation that forms in the tropical regions of the Earth, over the tropical oceans of the Earth. Anywhere between roughly just south of Florida, so around like 90 to 100 miles south of Florida, to the equator, and then to the bottom part of Brazil. That's going to be your big range that tropical storms can form in, your location on the world map, basically, that tropical storms can form in. And that's all they are. So a hurricane, it's basically just a big spinning mass of air and wind and clouds and precipitation that forms over these tropical regions. So then what is the difference between a hurricane, a cyclone, and a typhoon? Well, all the real difference is that a hurricane is in the Pacific and northeast Pacific and Atlantic. Typhoon is in the northwest Pacific and cyclones are in the Indo-Pacific region of the world. And that's pretty much it. That's the only difference. Difference in name only. So, man, we're just speeding through this episode, aren't we? So how are hurricanes formed then? Well, to answer this question of how hurricanes are formed, I like to draw your attention to a car tire. So everyone knows that in cold temperatures, your car tires lose pressure, right? And in hot temperatures, your car tires gain pressure. Now, why is that? Well, you see, what happens is when, let's say let's say I live in the plains of Colorado and it's a hot spring day. Let's say it's 70 degrees, right? So I go and fill my car tires up with air and fill them up to 40 PSI. And then I'm like, you know what? There's still some good skiing right now in Breck. I'm going to drive up to Breckenridge. So I get up to Breckenridge and it's negative 13, let's say. Negative 13. And I look at my tire pressure and all of a sudden it's 36. What happened? Why did that happen? Well, all that happens there is when you fill up your car tires with air, you have all your little air molecules in there. And, those air molecules are carbon dioxide, oxygen, argon, nitrogen, all these different atoms, all these different elements. But you have your little gas molecules in there, and they're bouncing around. They're hitting the insides of the container. They're hitting themselves. And that is what causes the pressure, is the energy of them moving around and hitting the inside surface of your car tire. But when you chill it down, you're essentially removing energy from the gas. And what that does is it makes the air molecules move slower, right? Because if you wanted to make oxygen, which is a gas at room temperature, a solid, you would need to cool it down by a lot, right? You need to cool it down by, at least negative 100 degrees, if not even colder than that, and 100 degrees Celsius. It's more like negative 207 degrees Celsius to make oxygen a solid. But as you cool down your car tires, you're removing energy from the gas. And so those molecules begin to lose energy. And so they move around less and less and less. And they no longer really assume the shape of the tire. They start to condense and almost clump together. And as that happens, the tire pressure decreases, right? Now, what would be the opposite? Well, the opposite would be you heat up your car tires, right? And when that happens, you're adding energy to those gas molecules and they want to rise, right? Because they're excited, they're moving around, they're bouncing off the inside of the container, so they want to rise. And what happens is, as you're pumping them full of energy, the tire pressure goes up. And it's a similar phenomenon that we see with hurricanes. So generally, hurricanes or tropical storms, they form in tropical regions where the ocean water is at least 80 degrees Fahrenheit for at least the top 50 meters or 165 feet below the surface of the ocean. Now, what happens here then? So you have this warm ocean, right? But is the ocean itself the only thing that's 80 degrees? Well, no. And generally speaking, water can be around 4 degrees or more colder than the surrounding air. So the air is probably 84, 85, maybe 90, maybe 100 degrees. And so what happens here? Well, what happens is as the sun, imagine that you're in the northeasternmost part of Australia, right? It's a hot summer day. The sun is beating down on the surface of the water. Now, what's happening? It's doing two things. Number one is small amounts of ocean water are evaporating off, right? It's very humid. So they're evaporating up into the air. And the air is getting warm as well. The air is getting warm because the sun is beating down on the air, obviously, and the sea surface. And so what happens there is this now really warm, humid air behaves exactly like the air in your car tire, and it begins to rise. Now, so basically then you have this large mass of warm air that is rising up off the surface of the water into the upper reaches of the atmosphere. But what do you think happens underneath? Now, some of you may say, well, cold air fills it in, but where's the cold air coming from? It's a 95-degree day in northeastern Australia. What happens is a low pressure zone is created because there's no air to fill in that space. So this low pressure zone is created underneath this mass of warm air that is rising up. And eventually, that mass of warm air gets so high in the atmosphere that it begins to cool down. And when it cools down, then you're right. Then it becomes a mass of cold air that sinks. And as it sinks back down in the air column, filling that low pressure zone. But now all of a sudden, there's a low pressure zone above it. And what happens is it displaces all the warm air that was there originally, and that goes back up. And so basically what we've created is a convection current or a heat convection cell. And this is the same phenomenon this is the same way that water in a pan begins to boil, a rolling boil. It's the exact same phenomenon. The water that's closest to the bottom of the pan gets hot, and then it rises, and then it cools off, then it sinks, then it heats up, and it rises. So it's a convection cell. And that is how a hurricane forms. And so what happens then is the more and more of these convection cells you get, the larger the hurricane grows, because now the larger mass of air is that's actually moving. And so the more air that is actually moving up and down in this convection cell format, the bigger and bigger it gets. And when that warm, moisture-rich air goes up into the atmosphere and cools down, yes, the air sinks, but what happens to that moisture? The moisture doesn't sink. The moisture crystallizes and forms clouds. And so then that's how you get the massive tropical storm that you see. And so you get cold, unstable air up top and warm, humid air below. Now, why is it unstable air up top? It's unstable air because it wants to sink. But as it sinks, it's being replaced by new warm air that is rising up right next to it. And so you basically create a zone of low pressure, where at the very top of this storm, it's high pressure and it's warm air, and the very bottom is low pressure and cool air, and that is called the eye of the storm. And all that's going on there is the warm air is sinking down. And as that warm air sinks down through the eye of the storm, it cools down, right, because it's getting cooler, and warms up again. It feeds back into that convection cycle. So you basically then have two or more, dozens of these smaller convection cells around a central point, which is the eye of the storm. And that is all a hurricane or a tropical cyclone or any tropical storm is. And so, that first part that we were talking about, where the the warm air rises up, the water vapor rises up from the ocean and forms clouds. What is that called? Well, that's called a tropical disturbance. So that's right in the very, very early beginnings, before you even have clouds. It's just that rising of warm, humid air. And then you have the tropical depression, which is where the clouds begin to form, and that those convection cycles really begin to start, or convection cells really begin to start kicking in. And then the tropical storm is when the wind speeds reach 39 miles an hour. And then it becomes a hurricane when it reaches 74 miles an hour. And so what are the hurricane categories basically? Well, it's 1 through 5. And 1 is 74 to 95 miles an hour. 2 is 96 to 110. 3 is 111 to 129. 4 is 130 to 156. And 5 is 157 or higher. And so finally here, before we talk about why climate change creates bigger storms, jumping into really quick before we jump into that, what was the worst tropical storm ever in history? Well, the answer is Typhoon Tip. In 1979, it made landfall in Japan, and the maximum wind speed was 190 miles an hour. And it was so big that it was nearly half as large as the continental United States. And if you're interested in this, there's a whole website, hurricanescience.org, that has the history of the worst hurricanes and tropical storms in history. I encourage you to take a look at that. It's very interesting. But yeah, Super Typhoon Tip was the worst hurricane or tropical storm in history. It caused over 600 mudslides in the mountains of Japan, and flooded rivers resulted in 27 destroyed bridges and 105 dikes. Over 22,000 homes were flooded and 11,000 people were left homeless. It's very interesting history here. So that is basically it. That's how hurricanes and tropical storms are formed. So then really quick, before we finish off today's episode, why is it that people keep saying that as climate change gets worse, tropical storms will get worse? Well, let's think about that, right? So what is climate change? Well, climate change is basically just an increase in average global temperatures across every biome on Earth, across the whole planet, that causes a change in the climate, right? That is what climate change is. So then why would climate change cause an increase in hurricanes? I mean, after all, the climate has only increased by 1.5 degrees Celsius since the pre-industrial age, right? Well, that is the average. So the temperatures increase more in the equator and the tropical regions, obviously, than they do in the northern and southern hemisphere. Now, why do I say obviously for that? Well, for the same reason that the tropics are warmer than the northern and southern hemispheres. They get more sun, and the sun has, they're more direct on the sun. At the equator, there really isn't a spring and a fall or a winter per se. It's mostly just wet season and the dry season. And so the temperatures that we see are going to be more extreme in the tropics than they are in the northern or southern hemispheres as the climate increases, just because of the position of where that is on the planet, on the globe. And since tropical storms form in the tropical regions, right, what happens? Well, the warmer the water gets and the warmer the air gets, think about this, the warmer the air is, the higher up in the atmosphere it has to travel before it cools down and falls back to sea level, right? So, if you have an 80-degree ocean, that is going to create a much smaller storm than a 100-degree ocean is going to create, because in the 100-degree ocean, the air is going to rise up much, much higher than it will in the 80-degree ocean. And as a result, those thermal convection cells that we discussed are going to be bigger, they're going to be stronger and more extreme. And when that hurricane crosses out of the tropical regions into cooler waters, the temperature difference is going to expedite the speed of the winds in the hurricane, making it bigger and stronger. So, ladies and gentlemen, I hope you enjoyed today's episode. It was really fun for me to do. I don't think I've ever done a weather episode before. I hope you guys enjoyed this. And I will catch you all on Monday. I hope all of you have a fantastic weekend. And remember, everybody, as always, stand up and question everything.